All right, there we go. All right, oxidizing Ocaml locality. I don't know what that means. Obviously, the last ones must mean something different. But oxidizing Ocaml. Let's do this. This is brand new. This is from
Let's.
Jane Street. With me today, of course, is the young buck TJ. He has.
Resting my hand in your my face in your palm.
There you go. He has obviously a YouTube channel and a Twitch channel. Tej_DV. Correct?
That's correct. You can find me there.
And also Twitter.
True. If you want to see memes and Ocaml tweets.
Yep, a lot of Ocaml tweets. All right, coming from Ocaml, the Rust programming language has many appealing features. Oh yeah, by the way, why TJ is probably what someone's asking, because TJ's been doing a lot of Ocaml and has even played with this feature, and I myself haven't. For some amount of background, this feature involves making Ocaml have some features of Rust around lifetimes, correct?
Yeah, they're doing like a 3-part series, so hopefully we can do the second one later. And then the ultimate goal is like eliminating data races completely. So that's like one of the cool things that you can do.
Oh,
we'll
that'd be
get
sweet.
there.
We'll get there. Okay. Yeah. Coming from Ocaml, the Rust programming language has many appealing features. Rust system for tracking lifetimes and ownership allows users to safely express patterns that are awkward in Ocaml, such as stack allocated values in custom allocation schemes, managed resources that can't be easily garbage collected, i.e. file descriptors or GPU memory, mutable data structures in the presence of concurrency. Okay. I think I understand most of those words.
Yeah.
I'm curious
like,
why,
like some...
even this, like, don't you just hold on? Oh, yeah, because a file descriptor often is just a number, right?
Yeah,
and so
they're going to show... There's a cool example, actually, of that one. But just like for some additional context for people who aren't like as aware, right? Ocaml's garbage collected. I mean, it's kind of implied in this, right?
Yeah.
So doing stuff like actually managing, to put something on the stack instead of just allocating it to the heap and then checking for it later, that's like you have to have some scheme to tell the language it's time to do this versus it's time to do that, right?
Yes. And if you could do it, it'd be fast. It like greatly speeds it up, like order of magnitude difference.
Especially where you maybe need to like allocate this same kind of value a bunch of times, right?
Mm-hmm.
Or other things like that. So like, you got to think, you write Rust, you're like, oh, I can pick where the memory lives. But then you're writing Ocaml and you're like, I just let the garbage collector do it. What if there was an in between?
Yeah, that'd be great. Honestly, like I said, if I could just use Rust with the garbage collector, I'd be super happy because, there's times where I want the speed, but for the most part, a compiled language is fast enough. Right? Like just like Go. It's mostly just fast enough. There's only very few niche instances where Go stops being fast enough.
Yep.
All right. On the other hand, Rust's approach comes with trade-offs. Eschewing garbage collection requires careful consideration of lifetimes and ownership throughout the codebase. Emphasizing lifetime polymorphism can make type inference untenable, a design choice that wouldn't fit Ocaml. Not only that, I think...
Can we stop, though, and just say I'm really impressed? I've never seen you read a paragraph with that many big words and actually make it through.
I did.
First try.
I did. I made it through. I've really been training for years at this point to be able to read at an 11th grader like level, and I'm pretty proud of that. By the way,
are you like trying to do really good because I'm hanging out today, or like what's going on?
I would like to say that despite your insults, you still have your chair just sideways. Okay, it's not even my chair. You just have a chair in the background ruining this entire thing while insulting my reading skills. Thank you. And it got away. Did you see that slow move?
The slow disappear.
All right. Anyways, one thing I don't think they also mention here is just that in general, when you have to fully lifetime everything, it can become just even a design choice that was good in the moment can become a very bad design choice later on. And so there's like a lot of things in here that are just very interesting. All right. At Jane Street, we've been working on extending Ocaml to better support these use cases without giving up the principles that make Ocaml a convenient and flexible language. To do so, we're introducing a system of modes which track properties like the locality and uniqueness of Ocaml values. Modes allow the compiler to emit better lower allocation code, empower users to write safer APIs, and with advent of multi-core statically guarantee there's that mispronunciation. Data race freedom.
Good, though. Like, it's still the right word.
It was close. It was close. All in a lightweight way that only affects those needs. Okay, very interesting. I'm very excited, especially stack allocation. To me, this is like a W. If you could get stack allocations in any language, but mostly rely on garbage collection, it's beautiful. I'd love to see how they do this.
Yeah, I think the other thing that's interesting is as we get a little bit further, you'll see, but like they're making a distinction that I didn't catch the first time I read this about modes, which is like modes aren't in the same way like part of the types system as like lifetimes. So like lifetime is part of the type,
Okay.
right? But then
Oh.
so it's like in some ways a little bit orthogonal to the type itself.
Yes.
Which is so it's cool, right? Because as you played a little bit with Ocaml, they talked about you want to be able to always infer the type of something for Ocaml, basically like all the time, right? And so if this like effectively lifetimes light, this is like the first part, right? It's like lifetimes light effectively. If that was part of the type, you wouldn't always be able to infer it, and then you would have really, really sad times.
Yeah.
Right. So you just want it to be, I just want it to work. So that's basically what's going on.
Yep. All right. The first approximation, this model requires allocating all values on the
you skipped
heap.
the first paragraph.
I did? Oh, dang.
Yeah.
The Ocaml compiler does not statically track lifetimes. Again, reading skills. You know how many comments I get with, hey, you missed a paragraph.
You missed a key paragraph, and then you talked about it for 5 minutes.
Every video. Instead, it relies on a garbage collector to figure out a suitable lifespan for each value at runtime. Values are collected only after they become unreferenced, so Ocaml programs are memory safe. Yeah. The first approximation, this model requires allocating all values on the heap. Fortunately, Ocaml's generational GC can efficiently handle short-lived values. Minor heap allocations simply advance a ring buffer. Oh, cool. However, placing everything on the heap is still a pessimistic approach. Where possible, using a specialized allocator could improve performance. For example, the minor heap is typically larger than cache, so future allocations are likely to evict live values. Stack allocation would immediately reuse freed space, eliminating this concern. Okay. Exciting. Let's see. Providing an alternative to heap allocation would also have other benefits. Every minor heap allocation brings us closer to the next minor collection cycle. A minor collection incurs some fixed overhead, but more importantly, frequent collection causes more values to be moved to the major heap. Yep. Promoted values become much costlier to collect later on. So this is the difference between a minor GC and a major GC, really, in JavaScript as well. Very similar idea. I think they have some morbid term where the minor is called a nursery, and to kill something else called infant mortality. Some just real morbid term.
Yeah, I think they avoid using those phrases in this article smartly.
Yep. Just very big brain Ocaml programmer right there. Oh, yeah. Infant mortality's bad. Let's not use that. At Jane's...
Alec. Chat's making fun of M. Alec.
No, we're not going to make fun of M. Alec. Okay, it's called Malik for a reason. At Jane Stream, we often write zero allocation code, which must never trigger a GC cycle. I love this. This is actually a really fun to write zero allocation code. There's zero copy, which is really, really hard to do, but zero allocation is pretty interesting because you can just effectively create a bunch of stuff that you'll need and just continuously reuse what you have. So unlike your compiler, TJ, which you wrote to purely copy everything, this would be the inverse of it all. All right.
Yes. But my compiler mostly just lives in the minor GC, right? So it's still very fast because it's just like allocating ring.
Unless if we do too much allocations, then you bump all these little minor allocations to major allocations, baby. Okay, that ring buffer's of limited size.
I
Wait,
know.
Is the chair back? The chair is back!
Oh, whoops. I only have so far I can push it. There we go.
That sucks. But okay, whatever. That's fine.
Stuff, but it's fine.
It's close enough. Let's see, hold on. A stack allocator would make it easier to write programs that do not touch the heap. When such performance concerns are relevant, one should arguably be using a language based on explicit memory management, like Rust. However, garbage collection is genuinely useful. Explicit management is a burden on users. Ideally, a language could improve a spectrum of allocation strategies freely interoperable with a single application. With modes, a user can write Ocaml with all the usual GC guarantees, but when performance is paramount, opt into the consideration of lifetimes, ownership, and concurrency. Okay, I really like where this is going. So I hope
Big W.
I hope that we're going to get to the point of actually seeing what it does now. Yes, okay, local variables. Ocaml. Let's see. In Ocaml, it turns out that many short-lived values can be stack allocated. To safely refer to such values, we introduce local variables. Okay. Determine whether a variable is local involves checking a certain condition on its lifetime, considering the following function. Okay, so we have a function isInt, which takes in a single string. Opt is int of string opt in string. So that opt must be a option, yeah?
Yeah,
instead of throwing an error.
Raising an exception, yeah.
Yep. Okay, so you have this sum. Okay, cool. This seems pretty simple. You return true or you return false isInt. Okay, perfect. See, I'm kind of being able to read Ocaml. I haven't really written any Ocaml,
You're already there.
But I can read it, just not write it yet. That's just a matter of practice. Yes. Naively, this function incurs a heap allocation. The compiler does not know the lifetime of opt. Our function could return it, or even store it in a global variable. Because opt could escape this function, the value referenced by opt may need to live forever. Therefore, it must be heap allocated. Okay, that makes sense. Blah, 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 blah. As a programmer, however, we can deduce that a shorter lifetime suffices. In fact, opt only needs to live until we match on it. When isInt returns, opt is no longer accessible, so it could safely be been allocated in stack memory local to isInt. Okay, data stack, sum I. What is opt again? Just to make sure. Okay, opt is this thing option right here. It only needs to live this long.
Right, so it's
a
an
stack.
int option.
Yeah.
Yeah.
Okay, that
Right.
makes perfect sense. It only really needs to live very, very short. All right, specifically, hold on. Did I already read this part? Oh, no, we haven't read that part. Specifically,
You're
opt
right
is
here.
a local because its lifetime does not exceed the enclosing stack frame, which we will call its region. At runtime, entering isInt begins a region by saving the current stack pointer. Exiting ends the region by reclaiming stack allocated memory. Reclaiming usually just means you move the stack pointer less high in the stack. Since opt is only accessible within this region, it may safely be allocated in the corresponding stack frame. Beautiful. Note, stack allocated values is not necessarily stored in the control flow stack, as seen in languages supported by Alaka. In this example, we request space from stack-based allocator backed entirely by entirely unrelated memory. Okay, the locality mode. So, local variables are those that do not escape their region. To formalize this constraint in a manner the compiler can check, we introduce modes. Okay, so I love this idea. This is where we separate out the type of a lifetime like Rust versus an operational paradigm of the, like, you're really just changing allocators in Zig. Is that fair to say?
Yeah, although they're going to introduce some sort of like, because this mode is more than just a hint to the compiler, like you're able to do some stuff later, but that's like the first pass of what to understand is definitely that. Yep.
Okay. By default, variables have a global mode. The global variable has the capability to escape any region, so always reference the heap. Perfect sense. Variables with new local mode cannot escape their enclosing region, so may refer to the stack. Okay. A mode is attached to a variable upon declaration, either the let binding or a function parameter. In both cases, the compiler will check that value does not escape the region. Okay. Oh, so let local. Why? How does that? Let's see. Oh, so how does it know not to make this a function that returns 0?
It will literally be a change in the compiler. So right now they have a fork that you can like test out and you can do this. But like it will literally be a change in the compiler and local will become a keyword.
Okay, this makes sense because right now you could imagine that is just a function called local.
Yes.
Okay. This variable escapes its region.
So that's the error.
I don't really understand why is it escaping its region and not why.
It's well, why would also? It's saying both of them do, but like the first error prevents the rest of the compilation.
Okay, a local parameter represents a problem. Or, oh my goodness, a local parameter represents a promise by the callee. The function will not store a reference to the value anywhere that could be accessed after the function returns. Intuitively, it's safe to pass stack allocated value to a function. We know the value's lifetime will not extend. Okay, is empty, local string, string length equals 0. Perfect. Is it really just one equal sign? It's not 2?
Yeah, well, they do different things. The one is what you'd usually use.
Oh. Isn't that for assignment, not a quality check?
It's a different like operation based on where it is. Yeah.
Sorry, sometimes I don't know things. Sometimes I'm a little dumb. Let's see.
Okay.
Let's see here. The syntax string at local denotes is empty takes a parameter at the local mode. Okay.
So that second, the one in green is like the type of it, right? That's what you get when you're running utop and you execute it and it tells you what the type is. It says, hey, look, your first parameter is in the local mode, and then this thing returns a bool.
Okay. Here, the syntax string at local denotes the is empty. Okay, that makes more sense. I get this now. Even without explicit mode annotations, the compiler can statically determine which variables may escape their enclosing region. Such variables are assigned the global mode. All others are automatically inferred to be local. At this point, the compiler may construct values bound to local variable using stack allocations. Interesting. Okay, so it's up to the compiler. You're not really actually telling it to use the stack. You are just simply letting the compiler make that decision.
No. Well, so you can tell it by using the local keyword, but also like someone had asked in chat a little bit ago, but I knew this was coming up. Like
if it's already allocated on the heap, it just works.
It will do its best to figure out which things are local, like based on the code that's written when it gets compiled. And for those things, it will then put it into local mode, which will allow it to be put onto like the data stack instead of a heap, and then they won't have to get garbage collected later.
Okay, that makes perfect sense. So like local string, you can pass in a heap allocated item. It doesn't have to be a local explicit item. This just means if it can be heap allocated, it will be. But if it can be stack allocated, it also can be.
Yes,
whereas the other one is only heap only if you don't use local.
Yeah, they're going to talk about the interplay between which one's considered like a sub mode of the other. This idea will be expanded in like other directions throughout the other ones to add the other features that are like interesting about like Rust's like lifetime and ownership system later, which is why I actually sent you this one originally, because the next article I think was where it'd be like, oh, that's so cool.
Okay.
But anyways, this one still has a lot of cool stuff. I mean, this is cool, right? Because it's basically like, how often do you get to in a garbage collected language say, I want to put this thing on the stack?
You don't. Usually you don't. I don't know of any language. I guess I don't know Python well enough. Python seems to be able to do everything. So I don't know if you
with C.
Yeah, I know. That's the thing is Python. Usually the answer is yes, Python can do it. But JavaScript, you certainly cannot. That's not an option, or you don't plan on it being an option. Now, whether or not they actually allow for it, I don't know. Maybe if you do like simple integers and it's JITted, it might be able to do some stack allocation for some small lifetimes, but you can't control it in any sense. So local returns. All right. Oh, actually, hold on. So even without explicit mode annotations, the compiler can statically determine which variables may escape their enclosing region. Such variables are assigned the global mode. All others are automatically inferred to be local. At this point, the compiler may construct values bound to local variables using stack allocations. So this would also allow for faster compilation because it doesn't actually have to do like a full exhaustive searching. It just has to be like, do you escape? Oh, you escape, you're global.
Well, right now it will be slower because right now it just always assumes everything is global, right? Like compilation step. Because like right now it doesn't do any checking. Like when this is all the way done.
Yeah, when it's all the way done, but Rust is really slow.
Yes, so it will be faster than Rust's because I think it already is much fast. Like it's very fast compilation right now.
Okay.
But yes. Yeah. Okay. So I don't know. I wouldn't want to make any promises, you know what I mean? But like it should be simpler.
Okay. Let's see. Returning a local value from a function should appear contradictory since the function's result has clearly escaped its region. On the other hand, if a function can only return globals, constructing fully stack allocated values becomes difficult. They become built up from literals. The solution: enclave?
I don't know. Yeah, apparently it's a real word.
Oh, sorry.
I had to Google it as
I said N. I didn't even see the X. Like the X became an N for me. What's exclave?
Yeah. I don't remember exactly what the definition. I had to look it up, but basically it means we'll just
a portion of territory of one state completely surrounded by territory of another or others as viewed by the home territory.
Yeah, so it's basically like they're just going to surround that piece of memory or something like that. I don't remember exactly what the reasoning was for it, but they also were trying to pick one that wouldn't be a word that was used a lot. Because like if you did return or something like that, right? Like people are already using those words. So you need to pick something that's maybe a little bit less likely to be used.
Okay, I get that. It's also when functional bros get into it, the terms get exceptionally complex.
It's true.
It's true.
They got a lot of words.
They got a lot of words. A lot of words there. Okay, so
check out the type
right here.
That then,
it's
right?
a int list at local.
Right. So it's telling you that like this thing can't escape the global scope.
Okay. So I wonder if you can you do a local allocation here and then exclave it out?
Yep. Yeah.
Okay, so that's kind of like just passing. It's just, okay, cool.
Right. So that's basically the problem they're solving with it, right? Otherwise, they're saying you could only build it with literals, as in, Prime, Flip's telling you to check your Discord. Don't dox. You could lose this VOD and be out of content, he says.
Oh. What's going on?
I don't know. Flip is telling you to check Discord.
Very negative.
That would be.
He doesn't want me to leak the DMs, by the way, because his Discord froze and I took pictures of him and he looks real caveman-like. Anyways, okay. The exclave keyword ends the region and executes the given expression in the enclosing region. The caller receives the local variable here. I'm going to go like this. He's upset about that, Marker.
Marker, Flip, put the picture in, Flip. Do it.
Yeah. Put the picture in right now. All right, anyways.
Flip, do it.
Therefore, it's safe to allocate that value on the caller stack frame. The difference is simply which region the value lives in. Okay. So let list equals local list in list. Okay. List, this value escapes its region. Why? Porque? Oh, because this thing returns list.
Right.
which then becomes here, which it can only live within this in expression. So if you
Yes,
didn't do an
exactly.
in and you did 2 semicolons, then it could live right here because it'd live for the expression of bar, correct?
Oh, as long as it isn't returned, basically. So like you just can't return it.
Okay, you can't return it. Okay, local
Yeah.
returning functions are the primary method of creating stack allocated values, as they can programmatically build up local data structures. This mechanism allows for functions to return their local parameters. Lastly, recall that local stack is distinct from the control flow stack, making this behavior easy to implement. So they could do exclave list, which would then make it live to this level.
So if they did exclave list at the end of this, then bar would return a local list, which is legal. Like you can return it. It would be up to whatever the callers of bar are doing to make sure that they don't violate like the promise of what it means to be a local list. And by up to them, I mean like the compiler will tell them if they fail to do that.
Okay, that's good to know. Okay, locality in our APIs. Locality doesn't only facilitate stack allocation, it also lets us design safer APIs. The following code exhibits a common pattern for resource management with file mode read only. I don't know what this is. I don't know what these
So
tildes
those
are.
so that's just a named parameter. So when it has like a tilde and the name, so it's saying, well, we want to do the mode, then you have a list of modes that you can do, right? So this one's saying it can be read only. And then here's the function that you're going to call with this file, and it passes a file descriptor.
Okay. Well, why? Oh, because you can also define a function with fun, right?
Yeah. Yep.
Okay.
So, and then this is basically saying like, open this file and close this file for me, and like manage the files, like in a sense, right? This function exists already, and then do these things with the file in the meantime, right? That's what the callback does.
Okay, so this callback allows you to have effectively the lifetime for this. However long this function lives is how long this file's open for.
Yes, but they're going to show how you can like break that without the locality.
Okay, here a file descriptor is open, pass to the Lambda function, and close after the function returns. This API lets users eschew manually closing the file descriptor.
They really like that word.
They do.
Twice in one article. Nice.
It's a lot of eschewing. However, there's no guarantee that the descriptor is not used after it's closed. Okay, there you go. So you can do this, and then all of a sudden, boom, you now have stash right here. And then later on, you can close stash. I don't know what bang does. Some of these. This is where I get into the more advanced Ocamling.
That's just basically how you access a mutable value. So like you can't just pass around mutable values like regular values. To access the like inner value, you do bang.
Oh, okay. Weird.
Yep.
Okay, we'll have to get there. Of course, this design can be improved by making FD a local parameter after changing the signature with file the following way: file string open list file descriptor. Okay.
So the big important part is inside of there where it says file descriptor.t at local. So now it's saying, hey, we have a file descriptor and it
can only live
a local.
Yeah, it can only live within this function, and whatever you return is also returned on the outside.
Yeah, right.
Okay, that's type polymorphism. Is that the term?
The parametric polymorphism. Yeah.
Parametric polymorphism.
Because
There you go.
It's a parameter. It's just like classic generics that you'd think of in like TypeScript or Go, basically, right? Where you would like say that this is a T and it returns a T.
Okay. Yes.
Yep.
Okay. Let's see. The callback must promise not to stash away the file descriptor. Therefore, we know the file won't be used after the callback. Okay. Perfect. In this example, we're using modes to require a promise from the caller. This usage might feel similar to local returns, and for good reason. Formally, when a parameter is used contravariantly. There's one of those words again.
Yep.
What does contravariantly mean?
So, well, they'll explain it a little bit, but it's basically saying which one can be a broader or a tighter, like, I don't know what to say, genericism. I'm not sure exactly how to say it, but like, so contravariant, I think, is the way when it's saying like you can't pass in something that's bigger than this. So like if you think about for types of something, right? If you had like inheritance, this would be saying like, oh, if I'm an animal and a dog, well, I can't pass in an animal. I'm expecting a dog.
Okay.
Right. But if it was covariant, then it would say, oh, well, since dog is an animal, then you can do it. I think I did it right, but I keep on forgetting which way it is for which words. But that's the goal of how to think about it. And I never remember which word goes to which. So that part doesn't really matter. But the idea is whether it allows you to go broader or tighter of like a type.
Okay. So narrowing versus broadening. So one of these two mean that you can pass in a dog to an interface that takes animal. The other one is you cannot pass an animal into an interface that takes dog.
Yes.
Okay. Yeah, I don't know. I've heard these terms, but I always forget what they mean, and then I get into this
Yeah.
situation every single time where I go, I don't even remember which one it is.
Your intuition though is like correct about it in that like it would make sense to you if you saw something was a function took in a dog. You're like, well, I can't just pass in any animal.
Yeah.
Like it's
Yeah.
specifically saying dog, right?
Yeah.
That's exactly what they're saying here. This one says it's taking in a local, so it has to be a local. It
Okay.
can't be a global.
That makes sense. Okay, that makes sense.
So then, just to be clear, if we like scroll back up to the code example,
Yeah,
with
I
the
remember that
ref-
one because that's the
Oh
one.
yeah, down a little bit.
Well,
more.
I was also thinking about this one. This
Oh,
one allows you to
yep.
take in a local string, but it
Yep.
doesn't necessarily require it to be local.
Right, it could be a global.
So how does this one denote that this one can't be anything but a local?
Because since or wait, maybe you're right. Maybe I am thinking of that backwards. I have to think about it a little bit for the string one.
Just
Because yeah, I don't know. I have to think about that one a little bit more. Actually, I'm not sure. Maybe you can't pass a global to that one.
Okay. Well, I'm curious. Yeah, that's why I want to play with this. Okay, modes versus types. Above, we declare a local integer x using the syntax let local. Notably, we didn't simply add a type annotation. The local mode does not operate on types. In fact, the mode of x is entirely separate from the type of x. Beautiful. That way we don't have all the Rust stuff. Types describe data structures, that is, how to build up and take apart values. On the other hand, a mode encodes a property independent of data layout. So may be attached to a variable of any type. To illustrate this behavior, type annotations specify a variable at a mode using syntax type at mode. Okay, local, 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 right? In this case of locality, the salient property is whether a value may escape its region. Variables with the global mode can escape any region, so global variables or global values are correspondingly heap allocated. Conversely, the local mode restricts a variable to its region. A local value may be stack allocated. Maybe, is that the key word that they may not always choose?
Yeah, it's up to the compiler. Like you can't necessarily like guarantee it. I think, or maybe like later they will, right? Like, but because this is still just in like Jane Street's fork, right? They're like working to get this upstreamed at some point and getting community feedback and all these other things, etc. Right?
Okay, etc. Okay.
Yeah.
Encoding locality. Is this me gathering community feedback?
Sure.
Am I being used by Jane Street? Jane Street, I'd love to take a sponsorship. Okay.
There we go.
Look at that. We got two of us right here. Two
Right here.
influencers, tech influencers.
Tech influencers.
Tech.
But we just told people not to listen to tech influencers. So now what?
You should listen to tech influencers. You know what I mean? When it comes to me making hundreds, if not thousands of pesos, you need to listen to me, okay? I've played myself. Damn it, I've played myself.
We just Uno reversed ourselves.
I know. This is terrible. Okay, encoding locality with the mode has some advantages compared to Rust's type-centric approach. In Rust, reference types are parameterized over specific regions represented by lifetime variables. This design is more expressive than locality, which only distinguishes values that may escape all regions from those that cannot escape any. It's simpler, and I think I like it more. It makes your brain, it's just like a super simple
and
view.
like they're going to talk a little bit about it, but the thing that I like is like most of the time that distinction is basically all you need, right? Which is like, can this go anywhere or is it going to stay here? Right. Which is like most of the time what you have with Rust is like, well, I just want to say that this thing basically lives forever.
Yep.
Or it can't live any longer than this like function approximately, you know? And so like it's, I like where this sort of idea is for a language with garbage collection, right? Which like the in-between times you just let the garbage collector handle it.
You let the garbage collection handle it, but I mean, there's plenty of stack stuff that you're just like, I wish I could put it on a stack. All right. On the other hand, lifetime variables are a source of pervasive complexity. When references are inherently polymorphic, essentially all functions become lifetime polymorphic as well. For example, whenever a reference lacks a lifetime annotation, an implicit lifetime variable appears. Yes, exactly.
Yes.
It's kind of like
which is kind of
what was that?
It's like nice, except that it's annoying because then as soon as you need to start adding lifetime annotations, it's like boop, boop, boop. Every single function I have to add this random syntax for it, and then I have to like mark the ones, and then oh my goodness, well this one actually isn't exactly the same, can be shorter, and then
Yep. And then you get into this whole A/B problem, which is like now you have two references in here. You have two different arguments that both need a lifetime on them. Do you make them separate lifetimes? Do you constrain them both to the same lifetime? Then you have this whole like leaking of problem, and then it just goes on and on and on and on and on and on.
Mm-hmm.
Since Rust supports first-class functions, the result is that higher-order functions require higher-order polymorphism, which is a type inference is undecidable in general. Okay. Ocaml's modes do not affect type inference. They preserve the types of existing code, so users truly don't need to consider modes they aren't actively using. Beautiful. In Ocaml, type inference, higher order functions, and garbage collection are all important parts of the development workflow, so we consider the local mode to be a good fit. I'm liking this. This seems really nice.
So the one where you run into it a lot, the example that they gave for us is like, but if you try and write like a closure and you like capture anything, it's just done for, right? You know what I mean? You end up always having to like parameterize the entire closure over all the values that you want to do. Otherwise, you have to annotate all the annotations of those and make sure the closure can't escape anywhere, and you can't reference those things longer than this, or you have to say that, right? And then you're like, holy cow, like I just can't use closures that way.
Yeah.
Which is
also
like there's trade-offs, right? It's just a trade-off. Yep.
And then you just call string.clone. That's really what you end up doing, is that you make your own garbage collection.
You type move in front of your closure, and then you clone a bunch of things into it.
That's pretty much what I've done every single time. All right.
Yes.
Above, we noted that the mode describes property independent of data layout. Such properties are deep as opposed to shallow layout encoded by a type. To understand this distinction, considering the following type. Okay, so this is a list. I don't quite know what this is. This is it looks like a whatever the type.
So you just think of it as
generic
a generic.
Generic T is either empty or more of A, or a tuple. Is that a tuple of A?
Yeah, so it's like the head and then the rest of the list, which could be empty or it could be more list.
Okay,
right.
Head and rest of the list. So you're creating like a tuple that gets deeper.
Yeah, it's just a linked list, basically, right?
Okay. Destructuring a value of tick A list produces two possible outcomes: either the empty list or a pair of value. Let's see, a pair of a value and another list of arbitrary shape. Hence, the type only describes the value's top-level structure. All right, process, list, head, remaining. Okay. Conversely, there's that word again. They're getting all close to those words. Destructuring.
Eschewing the destructuring of.
Man, I'm just too stupid for this. Destructuring a global variable of type tick A list produces either a empty list or a pair of global value and another global list. That is, the root node of the list may escape its region. The subsequent nodes clearly can too, so the entire list must be heap allocated. Okay, more. Perfect. The same logic applies to local case. Destructuring a local list produces a local value and another local list. It is possible to create a local list consisting entirely of stack allocations, so we must ensure the contents of the local list also do not escape. Okay. Exciting. Deepness enables the compiler to validate usage of local data structures. Okay, so local list, do this, and this returns, right? Don't we need to exclave this? Where's the exclaving?
Well, so that's what it's going to say.
Oh, this value. Oh, this value. Okay, so I am getting this.
You're on it. Yeah, you're right on track.
I'm right on track.
You're following perfectly.
Okay, if locality didn't exhibit deepness, it wouldn't be very useful. If we could stack allocate the root node of the list, but we'd have no way to express that further nodes, it may also be stack allocated. Okay, cool. Submodes. Given deepness, locality might appear to be an all or nothing choice. So far, we allocated our data structure entirely on the stack or entirely on the heap. Yeah, that's kind of how I've envisioned it. To break this dichotomy, we will explore another important property of modes. Each mode access emits a natural subtyping relation. Okay, this might be the part where I get too dumb. In case of locality, it's intuitively safe to use global variable as if it were local. Absolutely. For example, a function expecting a local parameter promises equivalent behavior whether or not the parameter actually lives on the stack. Perfect. Therefore, we say global is a submode of local. Interesting. Which makes perfect sense, but still interesting.
Yeah. It's weird because, like, generally you think of, like, just when you're thinking of globals and locals, you're like, locals are kind of like a subset of globals, right? But, like, they're talking about it in a different relationship.
Yes, because there are always more globals than locals. There minimally has to be some level of globals that cannot exist locally. So,
you
therefore,
have to do something sometime. This isn't Haskell.
This isn't Haskell. We're doing things. So submode really isn't about the number of things.
Right.
It's not a subset. It's the places in which it can operate.
Yeah. And like it's about
or not even that.
It's actually about like which direction. Just think about it as like local is
constraining,
kind of
yeah.
like animal and global is like dog, right?
Yep.
Like that's how you should just think about it
Other way
as
around.
like the
Global
no,
is
because
like
global
dog.
is a submode of local. So like anywhere that you could use a local variable, you can use a global.
Okay.
But
Okay.
anywhere you could use a global is not somewhere you can necessarily use a local.
Okay. I think okay. Yes. Correct. And allow global values to be used at the local mode. Okay. Let localize x and exclave x. Does this mean
And
you
the type
take a
signature
global
tells
one?
you what it does.
Yeah. It just takes. This is a function that takes in something that's global and must make it into something that's local.
Yeah.
Okay.
And so that's why they said before, locals may be on the stack. I'm pretty sure. I don't actually know because I haven't read this. I don't know the implementation like actually. You know what I mean.
Yeah.
But like, that's why it's may, because like you could basically move a global into like a local with this kind of idea and restrict what you were going to do with it, right? I think that's kind of what's going on.
Okay, so you could potentially have two different uses. So even though this will always still live on the heap, it's now restricting its usage of it in some sense. Okay, it is
as far as I can tell. Yep.
Okay, it is safe for a local value to reference a global, but not vice versa. Let's see. At runtime, this means we can create pointers from the stack to the heap, but not from the heap to the stack. For example, we can create a local, fully stack allocated list whose nodes refer to heap allocated values. Let's see. All right, let's see. Recursive localized list, exclave this list with either empty or the head remaining. We're going to recall. I don't know what more does. What is more?
It's like making an enum. So that's like the you know how in Rust, if you had like a list, you'd have like list : empty, list : more. They don't have the : here, like because they're contained inside of one type, right? So we made this like list type and it has empty or more. So when you call more, it's not really calling it. It's saying this is more with this data. That's the data that's inside of there.
Okay, so this localize a list, so it creates a list of references. Yeah, so this effectively creates a list of references to something on the heap, but this list is allocated on the stack.
Right.
Wild. I'd have to think about that for a little bit. I mean, I get conceptually what they're doing. I'm just trying to think of why would I use this and when would I want to use this. It's hard for me to envision what to do here.
So the way that I was thinking of like why you would want to do this is if you have to do lots of iterations over this, you're going to do a lot less pointer chasing, right? Like because like all of your like pointers are actually on the stack, right? So you can just like locality, zoom in like CPU locality, right? Like zoom through the memory, and then you're only referencing those out to the when you need to go check the value, right? Because the value may be too big anyways for your stack and stuff or whatever, right?
Okay, so this effectively takes indirect pointers and turn them into direct pointers.
Yes, I think so.
Or single pointers.
That's what the picture makes me think of as well. So I think we're matching up with the picture.
Yeah, because now you're just okay. I think this makes more sense. Okay, we could create local list where the only first node is stack allocated. Say if we locally append to the global list. We could create a local list where only the first node is stack allocated. Say if we locally append to the global list. Local cons, local head remaining, and let's see, exclave more head remaining. Okay, so
I don't know why you would do this one.
Yeah, like, I don't quite get this one because okay, so the head is local. That must mean the list is local as well, but the remaining is global.
Yeah. So I think they're not saying that each of these is useful. They're showing the deepness of the types.
Yeah.
I think is like so they're just trying to show the different ways, and like lists are pretty easy to picture.
Yeah, I guess so. Yeah. The problem is sometimes these type of operations make me more confused than anything else. I think I see what's happening.
They should have just stopped with the first two examples and then maybe, I don't know. But I think they're just trying to show how you can do like more things if it made sense. But I'm not really sure.
Okay. Let's see. What we cannot create is a global list containing stack allocated nodes. Okay, that makes sense. Again, modes are deep. So any global list must have only captured globals. Yep. This preserves the invariant that whenever a node is heap allocated, all nodes reachable from it are also heap allocated. More rigorously, we could say that as we traverse a value, the current mode monotonically increases with depth. Nice. This restriction should also make intuitive sense. This sounds like my teacher teaching me computational theory. It's intuitive, and I'm like, I don't think you know what that word means.
You should have gotten this already from the first sentence, but if you're an idiot, I'll give you a paragraph.
Shoot. Since any list without a property contains a pointer from the heap to the stack. Let's see, hold on. This restriction should make it intuitive sense. Since any list without this property contains a pointer from the heap to the stack.
Check what Judo said in chat. Okay. He's not wrong.
Let's see. Monotonically, this gets nerds erect. This does. That's why there's even an entire clock called the monatomic clock. People love it. All right. Such a pointer is potentially used after freebug. The heap node may still be reachable after the stack has been freed. Okay, so this is effectively what they're saying is that you start with a depth of 0, if you will, and then once you move to the heap, it's a depth of 1. Therefore, you cannot go back to a depth of 0.
Right, exactly right.
If I got that correct.
Because then that's going to be real bad when that stack gets cleaned up and it no longer points to the thing you thought it did anymore.
I think you could re-say all of these words, which are all very fancy and beautiful sounding, and have the word globalist in here. I think it'd be a little bit easier to say that stack memory can refer to heap, but heap cannot refer to stack.
Yeah. Agreed.
Hey, maybe I could be a writer one day. Me and ChatGPT, we're getting after it.
In a sense, you kind of are. Like, if you think about the YouTube videos that you make as the sum total of your writing prowess, then
that is not a good prowess to brag about. The above layout can can be represented using Rust lifetimes, which supports subtyping. However, safely manipulating such data structures requires significantly more reasoning on the programmer's part. Agreed. This is where it totally sucks.
Check.
Checkmate. This is just like where Rust gets horrible when you start getting into these weird lifetime problems. Lifetime variables. Again, it's super fast though if you can be good at it. But I just don't have enough, like, the problem is I don't write enough libraries to be good enough at it. So instead, it's like every time I do it, I kind of go, okay, I know what I'm trying to do. Let's start trying to do it. And then when it doesn't work, I get frustrated. And it takes me like 5 tries. I'm like, okay, I got it. And then it works, and then I change one thing, and then I have to rethink all the things.
Yeah, or like you move to make it go async, and then it just starts feeling really bad.
Then you just feel sad about yourself, your life, and your situation. Locality offers a compromise. Consider just one lifetime. The current region makes efficient stack allocation easy to use in many practical scenarios. Values with other lifetimes are still managed by the garbage collector. Okay. The global record fields. Because modes are deep, a local record always contains local values. Hold on one second. How much more do we have? Okay, we're almost to the end. Nice. I was about to say, this is a long article. However, since global is a submode of local, inner values may also be heap allocated, and sometimes the programmer knows they always will be. In this case, locality isn't necessarily restrictive. Therefore, we support annotating record fields with the explicit global mode. The compiler forbids initializing a global field using a local variable. Global fields are hence allowed to escape their region. Yep. Okay, so you can be a globalist if you need to.
Yeah, you can just be a hidden globalist. You're like parading around as a local, but then you're actually a globalist.
Oh, damn. That's a conspiracy type. Explicitly mutable record fields are automatically considered global. If this were not the case, a function could leak a local variable by storing it with a local parameter, violating region safety. For example, we have a mutable X, option this, clear local box, local Y, none in this. Okay, so I don't quite
get basically
this.
Like fields can be mutable or not mutable in Ocaml. You set it at the field level. So like they said X is mutable, right?
And then we assign a local Y into a local box, but they're at different levels.
Yes. So then now like the box is going to get the box, you're in trouble. You're returning this box so it's like, hey, you can't just put this here. You said this was local. What are you doing?
Yes. Okay. For those that don't see what's happening here, this is a scope. This is a scope. And so Y lives this long. Box lives this long. Therefore, this cannot happen.
Yeah, basically that's the case, yeah.
Okay, cool. That makes sense. That makes perfect sense. Locality in practice. At Jane Street, we've been using locality in production for some time. Developers who work on performance-sensitive systems use locality daily, and those who don't are largely unfamiliar with the feature, which means we've successfully limited the cost to our users who care. Therefore, we consider locality's expressivity and performance benefits worth the additional language complexity. I agree. If you could do that, oopsies, wrong way. If you could do this and people don't realize they're using one of the two, to me, that seems like a W. That means you've created a feature in which is not leaky, right? The outside doesn't need to know about it. Only the inside does.
Yeah, and when they say they've been using it in production, that means like a lot.
I would assume they do a lot of things.
With how much Ocaml they have. That's not like, oh, we launched it and we've got 8 users. You know?
Yeah, we have a CLI that Tom uses to compile JDiesel, right? Like it's actually,
Yeah.
it's more than just for geniuses, is what you're trying to say.
Yes.
Okay, building on locality success, the compiler team is now implementing additional modes for describing ownership constraints. In part 2, we'll explore new mode access represented uniqueness and linearity. Okay, that seems
That's
crazy.
ownership, basically.
Okay.
Those two together are ownership.
Okay, well, I love where this is going. I'm very happy. I feel like I could love Ocaml. I'm still on the I don't know yet list. Okay, I still don't know, but I feel like I could love Ocaml. And reading stuff like this, where you get practical performance without like massive unsafety of C, where it's just like sometimes it's such an annoying. Like if you've never worked out segmentation faults, it's super not fun. Or Rust, where like you said, you go with all these references and then you go async and then you hate your life, and then you're just like, why do I hate my life? And you're like, oh, it's because of all this. Yeah. So I love this. This is beautiful.
I'm very excited for the next one too, especially if you get a little bit of time to practice some Ocaml this week, and then you'll start. It's gonna look like just like some Rust stuff, and you'll be like, "Oh my goodness, so sweet that I don't have to think about it all the time."
Yeah, it doesn't leak outwards, I assume, right? Which seems
one of the
amazing.
Things. There's a really great podcast, Signals and Threads. I haven't been on it. If they ever want to have me on, I'd love to.
TJ hasn't been on Signals and Threads, by the way. Signals and Threads, if you're wondering.
But they talk about how a lot of the goal of what they're trying to do for this is like make the complexity very much opt-in, which they like mention at the end, right? But the idea is like you don't have to pay for the complexity on day 1 learning the language, right? And maybe not even day 100, but it's like when you run into the problem, then you have the tool to solve it without having to resort to something like completely different, right? Like, oh, we just have to rewrite this part of the stack in Rust. You're like, oh, dang it, you know?
Yeah.
Like, okay. So that's what I'm excited about. So, anyways, this has been the Education-a-gin.
Yeah, this is the. Hey, don't do that. That's my line. Hey, it's completely inappropriate. And I don't go underneath. I go to the side. Okay, you got to go to the side. All right, that makes a big difference. Do you understand?
The Education-a-gin.
Okay.
Let's listen to this man's screams and be influenced.
Get influenced, kid. All right.
Get influenced.
The name?
And quit your job.
Oh God! Tune in and drop out. What did Timothy Leary say?
Buy my free course on front-end masters and get bankrupted.
What? All right. Hey, the name is Tej_DV. All right. Bye, TJ. This is ridiculous.
Okay, bye, chat. Love you, everybody. See you later.